Okay, back here with some examples or ALEKS examples of binomials. Remember, I did a video, it's back in the index that explains what the binomial is, kind of where it comes from in the development and kind of all the ideas and theory behind it. Right now, we're just going to focus on using it to do specific problems in ALEKS. So if you want a little more information on it, be sure to look back at that video. Um, We're going to just start with calculating basic binomial probability. And here we are given a scenario, and typically you are given some sort of scenario in the context of a problem. And it says here that a website administrator estimates about 12% of all visitors are looking for other websites. Okay. Assuming this estimate is correct, find the probability that a random sample of 5 people exactly are looking for it. Now, this is a little bit tricky the way this is worded because they give you this percentage in terms of looking for other websites. We're interested in looking for the websites, okay, where we're looking for the websites. And so we just got to be careful how that information, and it's easy to just read over this very quickly and look for numbers like, this would be the N, this would be the P, and this would be the value we're interested X is equal to. But here they're actually giving you the value of the complement of a success, right? Because we're looking for people that are actually looking for the website, okay? So this is saying 12 are looking for others. So our P actually, even though it isn't clearly stated here, is going to be equal to the complement of 12%, which would be 88%, right? 0.88. And so that's important to know, okay? Now, I'm glad I picked this one here. This one popped up first, I should say. I didn't actually pick it. I'm at the mercy of the computer here, but now it's easy to assume that's P, okay? Now, some of them, the number they do give you is P, but here, again, by reading it carefully, we see that it is not. It is actually the complement, 0.88. And so, we could, we're going to use the calculator. There's an ALEKS calculator right here to calculate binomials. I'm going to get back to this because this is a little bit cumbersome to work with. I'll show you what I mean by that specifically after I show you the other methods. The one that is probably you're going to pick would be, either this template. Okay, this is an Excel template. I'm going to go over that. That's kind of emphasized to use this if you want. Okay. But using Excel, okay, Excel will be used for to complete projects and that sort of thing. So you should be at least familiar with it. And this template, once you download this sheet, has a bunch of tabs here with different types of calculators set up. And notice I have the binomial one set up here for you right now. This problem here, and all we have to do is enter the P's and Q. Remember, Q is always the complement of a probability of a success. So they're always going to add up to 1. So again, remember we had, I believe, we had 5 for our N. So I'm going to type in 5 here. And notice how it has all this num with an exclamation point here. These are just, it's unable to compute these values because it's only going to go up to where N is equal to 5. Okay, so you will see as we use this sheet and some other examples with larger N's, these numbers always get adjusted, I should say. We do have to put our probability of success in a success in. I'll get it out eventually, 0.88. So, here's the 12% they gave you, and here's the 88%. Okay, and then notice we get the mean and standard deviation. So all we are asked to do here is just find exactly 4 people looking for the website. So if I look at that for X equal 4, this probability X is equal to 4, and we want this rounded to 3 decimal places, that would be 0.359. Well, actually, that gets rounded up to 0.360. Okay, so I am going to type that in, 0.360. That's rounded to 3 decimal places. And I will go ahead and check my solution, and there you have it. Now, the other way you could do this is, remember I showed you in the other video, and if you hadn't seen this, there's that software I've been referring to, Staplet. If I go back to the main menu here, all we do is get into the binomial distribution, and then we'll again type in the 5 and the 0.88, and it'll plot the distribution here. And we're interested in 4, right? Exactly 4. And you can see there's my 0.359. It gives it to you in terms of a percentage. So you can just scroll over this, or you can do the exactly or less than or equal to. We'll get into that in another example, but you could just do this, or I think you can, yeah, we can type the number in here. I think, what did we say, 4? Okay, 4. And there's my 0.35 or 0.360. Okay, remember, sometimes we express probabilities as a percent, but typically ALEKS is going to want you to type those in terms of decimals. And notice I can't use the scroll feature once I type one in here. It's kind of grayed out, and so you don't, I guess maybe you don't get confused. But so those values right there would correspond to what we see here in this column. Okay, all those probabilities. All right, so that's one problem. I told you I'd mention this to you, and we wanted the probability x is equal to 4. The reason this is so cumbersome is what it's going to do is, if I would just type in the 5 and the 0.88 here, okay, and I put in 4, all right, and I hit equals, I must have typed something wrong here. Let me try that again. I wasn't paying that close attention. Let me try the n, which is 5. This was 0.88. Well, maybe that decimal place didn't go in. That's why it gave me there. And I want 4 here. Okay. Must type something wrong in again. Let me try that one more time. Random sample of 5. Oh, yeah. No, that was correct. 0.88 and 4. Okay. Now, what it's doing here is it's giving me 0.47. So if I slide this over just a little bit, so we can see these at the same time. Here's the less than or equal to. And notice here's our number 0.4722, just like we have here. And what this is doing, and now this should probably make a little more sense to you, that whenever I key this command in, it's asking for the n and the p, and then it's going to give you the probability less than or equal to that. So if I wanted to use this calculator to find out just probability x is equal to a value, I kind of got to be somewhat creative with this, and I'll show you how that's done. We actually have to enter in 2 commands, right? With the, again, we'll put the 5 and the 0.4 or 0.88 and the 4. But before hitting enter, what I'm going to do is I'm going to subtract the probability of, again, 5 and 0.88. And then I'm going to take away 3 or less. So if I start with 4 or less and take away 3 or less, that's just going to leave behind the probability x is equal to 4, which this should be 0.360. And sure enough, it is. Okay, so that's what I mean by a little bit cumbersome. This only calculates, say, numbers in this column. And yeah, we can find numbers in this column if we do some sort of arithmetic with these, adding and subtracting. And the same would be true with greater than or equal to. But like I said, I just, I would, I guess, stay away from that because it's just a little more confusing and probably time consuming too. So, I would use either, the Staplet command or the spreadsheet here. Okay. So let's get back into some other examples here. So that was one with the probability of exact. Okay. The mean and standard deviation, I'm not even going to go over because, like I said, it just, if you look at the spreadsheet, I covered mine up here. Let me see if I can drag down and get it. Move that up a little bit. So, okay. So anyway, you can get the mean and standard deviation very easily here just by looking at the these cells, and the same would be true in Staplet. Okay, so all you have to do is type in N and P, and you're going to get it. Okay, here it is in Staplet. Like I said, it's you just look in this little box over here. Okay, so pretty easily for the mean and standard deviation. So I'm not going to do one of those, but I will come back and let's do one that would be what they consider advanced. Okay, so let's do that. Okay, so I picked one of these, and so multiple choice test. We have 7 questions. Each is A, B, C, or D, and only one of these choices is correct. If the random guesses on the question, what is the probability they get at least 2 of them? So this would be kind of maybe more clearly explained if, let's just say they didn't even read the question, they just answered A, B, C, and D. Okay, they wouldn't even be influenced at all. So obviously, we're given we want to know what N, P, and the values that we're interested in, the probabilities, we want to find the probabilities for the random variable values. And so it says at least 2, which would mean 2 or less. So this is like the K, or the value X is, X that we're interested in. So it would be like, we want the probability X is equal to 0. Oh no, greater than or equal to 2, right? 2 or 3 or 4 or 5 or 6 or 7. Okay, so at least 2 of them. Okay, so so if we write that out, just key this stuff in. We know N, we know the values of X we're interested in. They don't directly give us the probability of a success, but since we have 1, 2, 3, 4 questions, then I guess we're going to kind of have to use, a little bit of thinking here. The probability of a success on any one given trial, getting it right, is what? 1 out of 4, 1 divided by 4, or 0.25. Okay, so if I go to my spreadsheet here, I'm going to go ahead and type this stuff in. And we're not interested in the mean or standard deviation, so I'll just kind of keep that off the screen. So we have 7 questions. The probability of a success is 0.25. And you can see now this goes all the way down to 7, and then anything below 7 is going to, again, be like an error message here. Okay. And since we're interested in 2, right, at least 2, that's the least it can be. Okay. 2 or more. So that would be the probability X is greater than or equal to 2, which would be 0.555. And rounded to 4 decimal places, that would be a 1 then, right? So be careful you read this here, because, ALEKS, it's going to mark you wrong. You can do the problem correctly, but if you don't express your answer in the format they're interested in or want you to, then they're going to penalize you. So let's go ahead and enter in our 0.555 and a 1 and check that problem. And sure enough, we got that correct. Okay. And I don't know why, I just always do this. I don't like typing the 0 before the decimal place. They do, but I don't know. I don't. I if I remember, I will, but I usually don't. And it's not incorrect to do so. Okay. So anyway, there's the solution there. If we were using the ALEKS calculator, that would get a little bit tricky. We would have to find the probability of, all of them, right? And if we want 2 or more, we'd have to take away 1 or less. So maybe I'll just do that for you here. So we're going to start with all the probabilities, which would be a 1. Okay, so let me type in 1, and then I'm going to subtract the probability of it being less than or equal to 1. So I'll put a 7 in here. I'll put in my 0.25, and I'll put in a 1. So this is, again, one of those things I'm just kind of showing you why you probably don't want to do it this way. Okay, so there's your 0.5551, but it's a whole heck of a lot easier using the spreadsheet. And again, the same would be true on Staplet. If I go over here and just change these things to be 0.25, and I think it was 7, if I want to mistake. And so now it means at least 2. We can actually use the terminology that they did. And this is kind of nice. And they, will highlight it for you also. But again, you have your 0.5551. Okay, obviously once I convert to a decimal. All right. So there you have for the binomial. Let me just check here real quick. We did the advanced, we did the basic, mean and standard deviation. Like I said, we just need to look in that box. And this one's even more basic than this one. And so that's pretty much all you have to do here for binomial, okay, in terms of the ALEKS problem. So I'm going to go ahead and end this video, and then I will see you again, so to speak, in the problems dealing with the third big idea, which we talked about normal distributions and normal probabilities. So we'll see you then.